Hi guys, so hopefully you saw the notes that were attached to your Google Classroom, and if you were able to print them out, awesome. It looked something like this. Just in case you were not able to print it out, here's what you can write on a piece of paper so that you can follow along exactly with the notes. This is the same thing that's on that piece of paper you were supposed to hand out. So let's go ahead and get started. If you need to pause this video so that you can write all this down, go ahead and do so. If not, let's read this together. So a train averages 40 miles per hour. And first off, what does 40 miles per hour tell you? I want to go back to ratios. Remember that 40 miles per hour we can think of as a ratio. So I know that 40 miles per hour, I can think about, this is talking again about miles per hour. And I want to point out that I can think about this as a ratio, miles per hour. There was also another R word. I can also think about this as a rate. I can think of miles per hour as a rate. So just hang on to that because that will help explain when we get to graphing. So there's this train. I don't know if any of you guys have ever ridden on a train. It's not super common to take that transportation anymore, but it averages, so it goes about 40 miles per hour between two different cities. So I want to use a graph to show that relationship between the time and the distance. So I need to show a relationship, two variables between time, and then I want to show this between my distance. So whenever I see something that I'm talking about a rate of time and distance, I'm going to use something known as the distance formula. So this is super important here. This is your distance formula. And I know that to find the distance, and distance is represented by D. Oh, you know what? I apologize. You're actually going to always use a lowercase d. That's just how the formula is. So I have my distance, and my distance is going to be equal to, well, whatever rate I'm going. So here I could say that my rate is 40 miles per hour. So my rate multiplied, well, how many hours did I go? Was it 1 hour? Was it 2 hours? So your distance that you go will always be equal to the rate at which you're going times the amount of time that you go. So again, this D is going to represent distance. Your R is going to represent your rate. And then this T, whatever seconds, hours, whatever time is being represented, this T is going to represent your time. So basically, your rate, you can think of, remember, your rate, your R, will always equal your miles per hour. Right now, my rate would equal 40 because I'm going 40 miles per hour. And right now, there's only 40 miles per hour. That could be any amount of hours. I don't know. So let's go ahead and kind of talk about a lot of this and how we can graph this relationship between my time and distance. So the first thing that I have, so for those of you that have to draw this, it's okay. I'm going to draw, this first column is going to represent my time. And my time is represented by what? In this case, by hours. My time by hours. And this I can represent by T. The next thing is I want to put my formula. And my formula is going to equal D equals R times T. And then after that, I want to put, here's my distance, and that is in miles, and that can be represented by D. And from this, I get what I would call an ordered pair. And instead of X and Y, well, instead of X, I'm going to put T, comma, D instead of Y. This ordered pair will show at T amount, so at T time, at a certain amount of hours, I'll go this amount of distance. So again, if I'm thinking about which one is my independent variable, T, your time is your independent variable. The distance I go will depend on the time I travel. However long I travel, the distance I go depends on that. So you can think of usually X and Y. X is usually your independent, so this is independent. Y is usually your dependent, so your distance. So now I want to plug in some numbers, and this is where sometimes students get confused and they think, well, what numbers do I have to plug in? And the key here is it's any numbers you think will help you graph and make sense of this equation. So it's really up to you. Again, it's an independent variable because you can independently put in different numbers that you want. So let's say, so I know that I'm going, my distance is equal to my rate times my time. Well, right now I know my rate is really 40. So let's say I'm on this train and I only go 1 hour. So I go time, I plug in 1, time is 1 hour. Then I'm going to go, well, I already know I'm going to go 40 miles per 1 hour. And if I plug this into my equation, my distance will equal 40. 40 is my rate, times, if t is 1, then I plug in, whoops, that should be a 1. And I know I get 40. My distance equals 40 times 1, distance equals 40. So my ordered pair is 1, I plugged in 1, and I got, my dependent, I got 40. So I know my formula will be my distance will equal 40 times, well, I'm going to plug in other x's, other t's. So let's go ahead, I'm just going to keep it simple. Let's plug in 2 hours. So what if I go 2 hours? Well, then my distance will equal 40 miles times 2 hours, which will equal 80. So now I went 80 miles. So I know my ordered pair, my solution would be for every 2 hours, I go 80 miles, 2, 80. Let's say I drive, or I don't drive the train, I'm in the train for 3 hours. Well, that's 40 times now 3 hours. So 40 miles an hour times 3, 40 times 3, well, I know 4 times 3 is 12. Add my 0, I get 120 hours. Ah! Okay, sorry, this just fell. So my ordered pair would be 3, 120. And lastly, I could put in 10, I could put in a bunch of different numbers, but to better graph it, I'm just going to stay consistent and I'll say 4. So I know for 4 hours, I plug in 4 for t. This is representing, again, t. I already have my rate, which is 40, which I got from my problem. So 40 times 4, that's 4 times 4 is 16. Add my 0, that's 160. So my ordered pair is 4, 160. Now, I could keep going on and on and on and on, and I could find a bunch of different ordered pairs, but for this example, we're just going to find 4. So now that I have all of my ordered pairs, I can go ahead and I can graph this. Now, since you always know, this is technically always x to the left, y to the sky, and if x is representing my independent variable, well, my independent variable in this case is actually t, so I can, instead of writing x to the left, I can replace x with t. This will be t, meaning that up and down, this is going to be represented by d. So I'll have my time here, and then I'll have, this is my distance. My distance is in miles, and my time, I can see is in hours. So this is being represented by your hours. All right, so let's go ahead and graph. So you can use a piece of graph paper if you want. If you're printed out the notes, you have a piece of graph paper. Now, I'm looking at my different times. If I'm looking at times, what number do you think it would be smart to go by? 1, 2, 3, 4. Yes, I'm just going to go by ones. So I have, this is 1 hour, 2 hours, 3 hours, 4 hours, and I know I can stop there. But what about my distance in miles? Am I going to want to go by ones if I'm looking at my distances that I need to graph? No. What do you think it would be smart to go by? I'm going to have to get all the way up to 160. So I could go by tens, but that would be a lot of tens. So I'm thinking more like 20s. So let's go by 20s. This will represent 20 miles, 40 miles, 60 miles, 80 miles, 100 miles, 120 miles, 140 miles, and 160 miles. So now I'm ready to graph. So I can show on my graph that for time, if I go to 1 hour puts me at 40 miles. a distance of 40. If I travel 2, I'm now at a distance of 80. So I graph 2 and 80, 2 and 80. Then I think for 3 miles, I go 120. So I'm sorry, for 3 hours, I go 120 miles. So 3, comma, all the way up to 120. And then the last one I found was 4. 4, if I travel 4 hours, I go all the way up. My distance is 160. And you can see if I were to keep on going and going, well, the more time, obviously, that I am in my train, the more distance I go. So here's sort of my graph that I have. And again, this makes sense right here because at zero time, do I go any distance? No. If I haven't traveled any time, I'm not going to go anywhere. So my distance is 0, my time is 0. But here I can see I have now graphed my distance. And yes, so that's sort of an example of your distance formula. And just remember, a huge thing is that your R is your rate. And you can always think of, again, it's a rate, or you can think of a ratio. It's a ratio of your, you can say, of your distance over your time. So my rate in this example, my rate here equaled R equaled 40 because I had 40 miles per hour. And then T independently alone represents, well, how far do I go? So I want to go over a couple of different independent and dependent equations with you. Actually, no, we're going to do some examples. So these are some examples that were from your homework yesterday that I accidentally gave to you before we had learned it, but I do want to go over these with you. So I'm going to get a piece of graph paper out. I would recommend you do so as the same. And we actually are going to go over, there were 4 problems that I assigned you from yesterday, and they looked like this. And I labeled them as optional, and it was 26, 27, 28, 29. And basically, I want us to, we're going to graph it and write an equation. So this is just practice. And I want us to practice graphing, graph. Let me make sure. Graph and write an equation. Now I want to go over these with you because they can be a little bit tricky. So, for example 1, this was number 26 on your ebook page, but you have, let's pretend it was an iceberg. So you had an iceberg, and all it says was that it moves 2 meters per 3 hours. It moves 2 meters per 3 hours. So right now, I'm talking about it moves. This is talking about a distance right here. This is talking about a distance. So I know that I can use my distance formula, which is my distance will equal my rate times my time. So if I wanted to plug in and make an equation, I know that my distance will equal, now my rate here, my rate is talking about meters per hours. Meters per hours. My rate is how many meters per hours. And then I can plug in my numbers. I know that my rate is 2 meters per 3 hours. So my rate is equal to 2/3. My rate is equal to 2/3. So here when I plug in R, I can plug in 2/3 times, well, I don't know how much time. It's going to depend on what I plug in for my time. So here's your formula. My formula is distance will equal 2/3 times my time. And we can check this out and also make sure that it's accurate. So let's say I were to set up, here's my independent variable, here is my equation, and then here's my dependent variable, and then here's my pair, my ordered pair. Well, which one do you think is going to be my independent variable here? My distance or my time? It is going to be my time because it is independent. Whatever I plug in my time, well, then my distance will have to depend on that. So my distance is going to be dependent on how much time the iceberg moves. So here, my independent variable, let's start plugging in so that we can graph this. And so I have my time, and then here I have my distance. So let's plug in 1. 1 is always an easy number to plug in for your independent variable. So if I plug in 1, so I go, let's say that this, oh, see, this will be interesting. So if I plug in 1 for time, that means my distance is 2/3 of a meter, because distance will equal 2/3 times my time of 1. So my distance equals 2/3 of a meter. So my pair would be, if I go 1 hour, I only moved 2/3 of a meter. Well, let's try if I go 2 hours. Then my distance will equal 2/3 of 2 hours. And I know 2 times 2 is 4. 4 divided by 3, 4 over 3. So I'm just going to leave that as 4 over 3. Or you can say 1 1/3. So I'll put or 1 1/3. So then my ordered pair, I can say if I go 2 hours, then I go a distance of 1 and 1/3 meters. And let's say I go 3. If I go 3 hours, well, then my distance will equal 2/3 of times 3 hours. And here I know that if this 3 is being multiplied and there's also a 3 being divided, it will cancel out. So D will equal 2. Or I can think 3 times 2 is 6. 6 divided by 3 is still 2. So then my ordered pair here is 3, 2. And so we can go ahead and graph. So my ordered pairs, I have 1 2/3. Well, let's kind of go here and add this first. So I only have 1, 2, 3 seconds, hours that I'm showing. So my time is in hours. And so I'm just going to skip a line and do 1. So there's 0, 1 hour, 2 hours, skip 1, 3 hours. And then here I have some fractions, so I'll do the same thing. This will be 1 meter, 2 meters, and 3 meters, and so on. So I can order, so for 1 hour, I know that this iceberg only moves 2/3. So between 0 and 1, 2/3, if I were to split this into thirds, 1 2/3 would be right around here. So 1, and then I go up 2/3. Here, if I have 2 hours, I can go up 1, and then I'll go 1/3, which is about right here. And then for 3, I know I go up to 2. So for 3 hours, it moves 2 meters. And so here is my graph. There is my graph. And you can also just think about our original, what it gives you. And I know that I move 2 meters every 3 hours. So I can see here, 3 hours, I go 2 meters. And since this is a linear line, I can see, oh, well, all the rest of my points follow along right with it. So I know that that is a correct distance. And then really quickly, so the rest of them, I'm not going to do the full graph, but I want you to practice writing equations. So example 2, if I have is an elevator, so an elevator rises 5 stories every 6 seconds. How can I write an equation? Well, my rate is talking about, my rate equals stories per seconds, and then I fill in my numbers. Well, I'm given it's 5 stories per every 6 seconds, so my rate equals 5 over 6. And since I'm talking about distance that I'm going in my elevator, I know that distance equals rate times my time. So my formula is D, my distance will equal my rate of 5, 6 times whatever time I plug in for T. So this is my equation. Again, this whole section is talking about having two different variables. So it's okay to leave it like this, because again, I can plug in a time that will give me my distance. One more. If a car moves 660 feet every 10 seconds. Okay, well here again, I can identify that I'm talking about distance. I'm talking about distance here because I'm talking about a car moving, feet per second. So my distance will equal my rate times my time. And I know my rate is going to be equal to, I'm talking about feet per seconds, feet per, seconds. And then I can fill in my numbers. Well, I have 660 feet per 10 seconds. So my rate equals 660 per over 10. Now, do you think I can simplify this? Do I have to leave my rate as 660 over 10? Remember when we talked about unit rates? A unit rate is when my denominator equals 1. That's going to make my life a lot easier. So I think 10, what do I do to 10 to get to 1? Well, I can divide 10. So that means I would divide 660 by 10. And so I get 66. Or you can think about a unit rate is always just your numerator divided by your denominator. So 660 divided by 10 is going to give me 66. So instead of saying, oh, I go 660 feet per 10 seconds, well, I can just say my rate is I go 66 feet per every second, per 1 second. So my rate is 66 over 1. Or I can just write that as 66. So my rate is 66. So I plug in that into my formula over here. So then my distance equals my rate of 66 times however much time I go. And that is my, that's smeared. And that is my answer. That is my equation for that. So hopefully that makes sense. Let me know if you have any questions. You guys have a homework assignment explained on Google Classroom, so make sure to turn that in, and I will talk to you guys later. Good luck.